Hello class, welcome to lesson 9.2, which is all about solving quadratic equations by graphing. By the end of this lesson, you should be able to solve quadratic equations by graphing, and you should be able to estimate solutions of quadratic equations by graphing. So let's start with talking about solutions to quadratic equations. Our solutions are whatever values where the graph crosses the x-axis. So whatever our x-intercepts are, those are our solutions. So our x-intercepts are the solutions. So if it crosses twice, we know that there are two unique real solutions. If it lands right on the x-axis, that means we only have one solution. And if it never touches, it becomes a no real solution. It never touches the x-axis. Okay, so let's start by practicing graphing. So if we look at our first one, and we have x squared minus 4x plus 3 equals 0. Remember, just like yesterday, we're going to start, let's find our axis of symmetry. So that equation, remember, is negative, and then we have b, which in this case is negative 4, over 2 times a. And there's no number there, so we assume it's a 1. So that becomes a negative 4, and we have that negative. So we have two negatives. That becomes a positive 2 is our axis of symmetry. So I know where x equals 2, this is going to cut my graph directly in half. Okay? The second step, let's find our vertex. And in order to find our vertex, we use our x value from our axis of symmetry. We plug it in, so we have 2 squared minus 4 times 2 plus 3. So we have 4 minus 8, which is negative 4, plus 3. So we have a negative 1. So I will write that in there. So we know our vertex is at 2, negative 1. So I have 2 and negative 1. And then if I look, my y-intercept is my last value, which is 3. My y-intercept is 3. So I go up to my y-axis where it equals 3. And it's 2 away from my line of symmetry, so if I go 2 units in the other direction, I know I'll have a point there as well because it's line of symmetry. And then my last step is to just plug in some other values. So I already know when x equals 2 what it is. So if I plug a 1 in, I have 1 minus 4, which is negative 3 plus 3. That gives me a 0. So at 1, when x equals 1, y equals 0. And based on my line of symmetry, if I go 1 unit on the other side of my line of symmetry, there should be a point there as well. If I connect my dots, I have my graph. Now, when it says solve the equation by graphing, I'm looking for both the graph and I'm looking for what values cross the x-axis. So in this case, it's 1 and 3. So x equals 1, x equals 3. If you want to write it with the squiggly brackets, that is perfectly fine. If you want to write x equals 1, x equals 3, also fine. Okay? But that's what I'm looking for. One thing, if you are feeling confident in your skills from the last chapter, if you want a little bit of a shortcut, we have x squared minus 4x plus 3. If we rewrite that with parentheses, I look, okay, what multiplies the 3 adds to negative 4? That's a negative 3 and a negative 1. So if I do x minus 1, x minus 3, and I say that equals 0, I end up getting, if I say x minus 1 equals 0, I know x equals 1. And if I say x minus 3 equals 0, x equals 3. So that would be one shortcut to solve. If you're able to factor it, those numbers should be the same as where it crosses your x-intercept, okay, or your x-axis. All right, go ahead and solve this one on your own. Hopefully you got -2, +4. If you have any questions, please be sure to reach out for some help. All right, example 2. Let's continue to solve equations by graphing. This time I have x squared plus 25 equals 10x. First, I need it to be in standard form, so I'm going to say x squared minus 10x, because I'm going to subtract it from both sides, plus 25 equals 0. Okay, so now it's back in my standard form, and I can continue solving from there. So, again, first step, my axis of symmetry, I have x equals negative, and then I have a -10 for my b, over 2 times 1, because there's that invisible 1 there. So that becomes the negative becomes positive. 10 divided by 2 is just 5. And I know if I want to find my vertex, I have 5. And then I plug it in, so I have 25 minus 50 plus 25. That equals out to being 0. My third step, where is my y-intercept? It's at 25. And then I can continue to plug in other numbers. But I know if I have a y-intercept at 25, I'm going to have to change the scale of my graph. So I'm going to count by 5. So I'm going to say 5, 10, 15, 20, 25. Okay? I'm going to keep counting by 1s for my x. So my vertex is at 5, 0. My y-intercept is 0, 25. I know my axis of symmetry is right there. So if I go, I'm 5 away from my axis of symmetry. If I go 5 on the other side, I have that. So I see it's going to be a really big U to connect and make my parabola. So in this case, my answer, solving the equation, is when x equals 5. This time, I only have one real solution because it's touching, the vertex is on the x-axis. Now, again, the shortcut, if you see that you have x squared minus 10x plus 25, and you know how to factor that, you say, I need something that multiplies to a positive 25, adds to a negative 10. That's a negative 5 and negative 5. So if I do x minus 5, that's the same as x minus 5 squared equals 0. And I know if I plug a positive 5 in there, that makes this parentheses 0. So I know that my only answer is that positive 5. Okay? Again, if you want to do it the first way that I did with the green writing, go for it. That's perfectly acceptable. If you want to try to do the purple shortcut method, or you feel like that's a better method for you, go for it. Use it. All right, go ahead and solve this one on your own. Hopefully you got -1 as your answer. If you have any questions, please be sure to reach out for some help. All right, example 3. We're still solving the equation by graphing. So if I move it over, I have x squared plus 2x plus 3 equals 0. Because I always want it to be equal to 0 on one side. I want it to be in standard form. Now, if I look for my axis of symmetry, I know I have a -2 over 2 times 1. So that just ends up being a -1. My vertex is going to be that -1, my axis of symmetry. And then if I plug -1 in, I get +1 minus 2 plus 3, or I get a +2. So I have a line of symmetry at x equals -1. So I have a vertical line at x equals -1. That's going to cut my graph in half. My vertex is at -1, 2. I have a +1 here, so I know it's going to open upward. And then my y-intercept is 3. So that's 1 away from my line of symmetry. If I go 1 away from my line of symmetry, I have another point. And if I just pick a couple of other random points, I can finish graphing. So if I plug in, let's see, I already have x equals 0. So if I plug in x equals 1, I have 1 squared is 1 plus 2 plus 3, or 6. If I go over to 1 and then I go up to 6, I have a point there. Go on the other side, make it symmetrical, and I have a graph. Now, if I'm solving the equation by graphing, if I look at that, I see it doesn't touch the x-axis. So that means that there are no numbers that make this equation true. There are no numbers to solve this. So you put the null symbol. This stands for null set, or it means that there's no numbers that will answer the problem. Now, if you were to have looked for that shortcut first and you said x squared plus 2x plus 3, and you said, okay, I need two numbers that multiply to 3 and add to 2, you'd realize there are no numbers that multiply to 3 and add to 2. So we know that is a prime. We can't rewrite it. So you can't use the shortcut on that method. Not all of the prime problems have solutions. Some of the prime problems do have solutions, which is what we'll look at in the next example. Okay, go ahead and solve this one. Hopefully you said it was the null set. If you have questions, be sure to ask for some help. Let's look at our last problem together, which is solving x squared plus 6x plus 6 equals 0 by graphing. If the integral roots, that's what we've been finding, cannot be found, we want to estimate the roots to the nearest tenth. Remember, integral sounds a lot like integer, which, remember, integers don't have decimals. Okay, so this is saying if it doesn't work out to an even, like -1, positive, let's see, that's 5, it doesn't mean that it never crosses, it just means that it doesn't necessarily cross at a whole number, okay? So we're going to look for those problems. So let's find our axis of symmetry. So we have a -6 over 2 times 1, or we have -6 divided by 2, which is -3. Our vertex is going to be that -3, and then we have -3 squared is +9, plus 6 times the -3 plus 6, or we have 9 minus 18 plus 6. We have -9 plus 6, or a -3 as our y. So I write -3 up here. So I know my vertex is at -3, -3. And I have a line of symmetry going through there. My third step, my y-intercept, is at +6. So 3, 6. So I have a point there. That's 3 away. So I have another graph, or another point right there. Now, if I want to graph some other points, if I plug in 0, oh, I already did that because that's my y-intercept. if I plug in a -1, I get a +1 out. So -1, I get a +1. If I plug in a -2, I get a -2. So that means that when I connect this, it doesn't go through any points exactly. So we want to find out what are those roots. So I look, it happens sometime between -1 and -2. I just need to know where does it happen between -1 and -2. I want to round to the nearest tenths. The way that you do this can be a little tedious, but if I look, is it nearer -1 or is it nearer -2? To me, it looks like it's closer to a -2. So if or -1, sorry. It's closer to the -1. So if I plug in -1.2, if I plug in -1.2, I get a positive 0.24 out. Okay, so I'm still above 0. If I plug in a -1.3, I get a -0.11. So I know it's somewhere between, the root is somewhere between -1.2 and -1.3. Okay? So I'm just rounding to the nearest tenth. So that's all the decimal places I have to go out to. I don't have to do more than one decimal place here. So I should only be testing -1.1, -1.2, -1.3, -1.4, -1.5. But you want to find two numbers that are consecutive. So like -1.2, -1.3. They're consecutive. They're right next to each other. And you want to see if you have a positive and a negative. You want to find out it's between those two. And then is 0.24 closer to 0 or 0.11? 0.11 is closer to 0. So we're going to say our first answer is approximately -1.3. Remember, the squiggly equals sign means approximately, or the word about. Okay? And then you would do the same thing for the next root. You say, okay, it crosses the x-axis right there. It's somewhere between -4 and -5. It's closer to -5, so I need to see which one is it. And then you can solve that way. All right, we're only going to be doing this for a little while, where you have to estimate. This is the only section, because then later in the chapter, I teach you a lovely shortcut that's going to be your best friend. But first, you have to prove to me that you know how to find those roots by estimating, okay? So why don't you go ahead and solve this last one on your own. Hopefully, you ended up with 0.2 and 4.8. Like I said, and like I always say, if you have questions, please be sure to reach out for help. I hope you guys have a fabulous day.